2.17.6, 2.18.1, 2.18.2. So let's get it, guys. It's 10:25 a.m. And I'm kind of worried because my mom is sleeping. So, yep, there it is. There the snores. We're just gonna have to deal with it because we don't have our own room, and that is a situation that God chose. Oh my gosh, Shelly Fasulian. Hello, welcome to the stream. It's been so long since I've seen you. Yeah, have you been? Give me an update. So we're doing this problem, right? The contour C is zt equals 3 cosine t. Are we parametrizing? What? Where t is between 0 and 2 pi. This is an ellipse centered at the origin, traversed once counterclockwise. Proof that there exists epsilon greater than 0. Okay, so we basically want to use the Cauchy theorem to reduce this to something else. Drea, what's up? Yo, where's Scott? And Tofu! Waalaikum salam warahmatullahi. Finally showed up. Dang. You missed so many streams. Anyways, bye. Good night. Okay, good night. Iris. But yeah, thanks for popping in. Pixie's so bored. She's like playing around. Hope y'all are good and having it. What you doing? You just doing? Yeah, I know, right? I'm doing my homework, so I just kick out. Oh my god. I like it. Sorry, my stupid cat. So we want this to equal to a circle with the radius epsilon, positively oriented, centered at -2 here. Alright, so this is gonna break up into 2 sections. 2i, 2 plus c dz, plus the closed interval of another circle centered at epsilon, positively oriented, centered at 2. 2i over 2 minus c dz. Okay, so here, find a partial fraction decomposition. This is so stupid. Talk more louder if you can. Okay. I don't know if I can, just because, like, my mom was sleeping. I did just wake her up. My bad. I think it's the loudest I could talk right now. So, partial fraction decomposition, what is that? 2 minus c, 2 plus c. Oh, wait, this is plus, this is minus. And then it turns into a over 2 minus c plus b over 2 plus c. So, partial fraction decomposition, right? You multiply the top and bottom, or you multiply both sides by this denominator. So then you get something like this. 8i equals big I, SpongeBob SquarePants, okay. Oh, wait, no, that's not math. And then 2 minus c here. There you go. And you solve from there. So this is what we have. We want to get it to this form, right? We want to prove it so that this is what we end up with, it, and it's true. Is that math? Yeah, this stream gonna be quiet. Yeah, I mean I'm pretty close to the mic, so it's just like a calm voice. It's not like you can't hear me, right? Okay, it's gonna be boring. Trust me. I did this for 2 hours last night, in the middle of the night, like 3 a.m. So clearly I did not get my full 8 hours, but that's okay. Why does this look hard? Two factors in the denominator can't directly use CIF. What is that? I forgot what that means. So use partial fractions. We rewrite it like this. And then we multiply it by both sides. And that is equals 2, and that is equals -2. Oh! And then split the integral. Identify the singularities. Deform the contour. Okay, shrink it. Okay. That's interesting. Okay, so when we see something like this with the denominator, a very scary denominator, all we have to do, and it's provided in the question, is to do multiply the top and bottom by that denominator, then you get this. So what do we do after this step? Once we get to this point, we plug in the values for 2. So we want the first value. Want to plug in 2 for the first value. Plug in smart values. So for A, we're going to plug in 2. A, 2 plus 2 plus B, the second one, we're going to plug in -2. 2 minus 2. So then you get A4 plus B4, right? And because it's 8i, big I, plus B4, then A becomes like an I, 2i. Because it has to both equal to 8i, right? If 8i equals A4, talk louder, I could barely hear you. Really? I'm really so close to the mic. Like, anyways. Am I the only one who wants to sleep in math class because math is boring as hell? No, no, no. I fall asleep in front of the professor so much. I think I even snore. I don't know. But yeah, welcome to the stream, Shilu Devi BC10. How's it going? How is my battery at 20% already? Oh my god. Sleep in any class feels good. I know, right? Like, that's like the best sleep you'd ever get. So, I don't know why, but this is confusing because A4 becomes A equals 2i. How does A4 become 2i? Conversation has been deleted. Okay. Okay. Can we go over 2.17.1? in detail. Like, I never done this. You're from? I'm from California. Welcome to Stream Zero. His profile picture reminds me of a doggy. That's why it's 10:35 a.m. My battery 6'7". Wow. I'm from where? Welcome to the stream, Shagun Rana. I'm from California. So, so we're trying to wait. Kosh? I already did that one. This is 2.17.2. Oh, my bad. Okay, next question. Class? No. This is just studying from home. Battery 4%. No! Plug in your charges, bro. What y'all doing? Everybody's low on battery. Like, even my phone is plugged in, like, while I'm streaming. It's always charging. So the denominator is screaming something. Should think partial fractions. So plug in 2. Now use the easiest trick, plug in 2. And a equals 2i. Right? Because, don't look at this right now. If we do ai equals a4, then a has to be 2i, right? Because 2i times 4 is 8i. And then if we do the same for plus b4, then b is also 2i. So this is the denominator, right? ai is over 2 minus c and 2 plus c. So plugging our values that we found back into this thing, we get 2i over 2 minus z. I don't know if y'all can hear my cat screaming in the back. He wants me to come out and play. But this is the value inside the integral that we found. It looks just like that. So just put in the integral back. 2i over 2 minus z plus 2i over 2 plus z dz dz. And now we want to shrink it, right? We want to shrink it because where the bad points? Contour centered at 0 that reaches plus or minus 3 on the real axis. I'm actually not from Earth, I'm from Saturn. Wow, oh my gosh, so that's what SCN would talk about in her song. Why is he?
What is that smell?
I don't know, it's probably him. Why is he screaming so much?
He wants attention.
No, he's just gonna ruin everything.
He never ruins anything.
Look at him, he's trying to sit on the laptop.
He come.
And he brought his daughter, oh my god. I have a query. You do these lives on regular basis? I do. What is the time? Hello, Crazy Pico. The time is 10:38 a.m. right now. Is that Schrodinger's cat? Basically, yeah. Welcome back to the stream for Kira. I remember you because of the Kira part. It reminds me of Death Note. Assalamu alaikum again, sister. Wa alaikum salam wa rahmatullahi wa barakatuh, Faiz Imran. Welcome back to the stream. How's it going? Where are you from? Oh my gosh, that's the most number one asked question in the chat today. I'm from California, so yeah. Welcome to the stream, Pixel Persona. How's it going? All right, so we turn these into integrals, right? And where are the bad points? The bad points are when the denominator equals to 0. So over here, the bad point would be when z equals 2, and also when z equals to negative 2. So we look at that, and well, what did we have initially for our integral? Like, It's like the radius is 3, the contour, the curvature is parametrized, right? The ellipse passes. The ellipse C is simply closed positively oriented at 2 and -2 lines. Side C, because the ellipse passes through 3, at equals 0, and t equals pi. 0 and pi. So if we plug in 0 to cosine t, then you get 1 times 3. That's where it passes through 3. If we plug in pi, we get 0 here, it becomes 1, and that's 2i. So 3 and 2. The contour in an ellipse centered at 0 that reaches plus or minus 3 on the real axis. So ellipse centered at 0. But how do we know about this? I just want him to explain because I'm looking at this. I think we get it from this right here. But I just want to ask. Why? Sam Tofu. Who else is from Saturn? Um, SZN. You're the future of Iran. Oh my gosh, thank you so much, Great Jane. I really, I take that as a huge compliment. You're doing cyclic integration. Cyclic? I've never heard of that, but I just heard it's like closed. But I guess that's what you call it. Cyclic. Are you a college student? I don't like saying my age, so I don't really answer that kind of thing. I never asked you this, but which subject is this? This is complex variables. It's in the stream title. Okay, so look at the contour. It's defined. Yeah, that's what I was looking at. So it's the parametrization of the curve. So split into real and imaginary parts. So the real part is 3. The imaginary part is 2 2 sine t. So when you recognize the shape, if you eliminate t, then you get the ellipsoid. Say, I forgot the ellipsoid formula, but it's x over 3 squared with y squared over 2 with 1. So this is ellipse centered at 0, 0. So yeah, when we look at CT or ZT, my bad, equals 3 cosine T plus I 2 sine T, then this is just cosine, this is just x, y equaling to 3 cosine T and 2 sine T. So 3 cosine T and 2 sine T. That's our x, that's our y. So just, if you eliminate T, you get x over 3 squared plus y over 2 squared equals 1. Centered at 0, and yeah, for the x-axis it goes like that, for the y it's 2. That's why it's an ellipsoid. Okay. Oh, my most hated subject. You did this before? In the news, Trump said open the effing Hormuz Strait. I think he was losing it. That was pretty old news. I saw him say that a bit ago. But apparently he got to do it. What? Here's Thursday. Congratulations, you got a new subscriber. Aw, thank you, she Ludevi. That's very nice of you. But yeah, it's Thursday here as well. It's just the morning. One more subscriber. Aw, thank you so much, Pixel Persona. That's so nice. The contour's integral is actually simple. Yeah, it is. I just tend to forget these things. Like, I'm not doing ellipsoids right now. That's like calculus 2 type thing. You have to be really strong on the basis to remember the small things. But are they inside the contour? So 2 and -2 are both inside the contour. Because this is a real number, right? The contour in the ellipsoid that reaches plus or minus 3 on the real axis. So these are in the real axis. This is the real axis, right, the x-axis. The y is the imaginary one. So that's inside the contour. So both singularities are inside. So these are called singularities. So key idea is to deform each separately. This is where people get sloppy, so slow down here. You do not shrink everything at once. You treat each term individually. So the first term, singularity at z equals 2. So the function is analytic everywhere else. So shrink the contour to a tiny circle. I'm going to call that circle epsilon. So shrink time, we do the circle centered at epsilon, centered at 2, right? So we want the center to be 2, but the circle to be bigger than 2. But yeah, so then 2I over 2 minus z dz. And then the second part, second term, we want to shrink that as well. What's the problem if I do it both at once then? Just put the bad point. Assalamu alaikum wa alaikum assalam wa rahmatullahi wa barakatuh. Coco, welcome back to this stream. Very nice seeing you back. I love when, yeah, I'm with some viewers during this stream. I saw your birthday video. It was sad, but still, I give it a like. Aw, I guess it was pretty sad. It was like, um, I was pretty alone on my birthday, but I was just saying to myself, like, how I'm gonna view the rest of the year. You know, you gotta have a good outlook on life, because sometimes you could lose that. I even watched that stream, birthday stream the other day, and I was talking about how I wouldn't want to change anything in terms of how I view the world. And I was like, dang, I can't believe I said all that because like I forget, you tend to forget how you see the world. Do you have a Discord? I do. I don't really have an official account. I just use it for school, because for my classes, it's not something that I use like um permanently, I guess. I have a lot of accounts, like I delete it every now and then. It's not really something. Don't worry, Allah still loves you. Thank you so much, Faris Imran. It means a lot to me. Because, yeah, your faith is not always going to be the same. It's going to be shaky here and there, but that's what makes it real, The, uh, the, the possibility of it going down and up, like, you know, we can all talk together. Yeah. Yo, welcome to the stream, AU. How's it going? Hello, hello. Hello, SK Atrangi. Welcome. Welcome to the stream. We're just doing some math right now. But if you want to talk about your day, you can. So if we put it together, that's exactly what we wanted, right? We wanted to prove that this part equals to this one. So the thing to remember is to just use um partial fractions. So step 1, partial fractions. And then you split it and then you find the singularities per integral. And you don't mix them. You cannot shrink a contour both around at once. Okay. Why? I literally just did that. Now I can actually compute those integrals using CIF. That's usually where the instructors go next. No, I don't want to compute it. I just want to prove it, right? What are you studying? I'm studying complex variables. I have a quiz today, so It's pretty simple when I go over it with help, like from ChatGPT and my assignments. But when you're in there, you tend to forget all these steps, all these things. Hi, hello, she Ludevi. Welcome. Oh, and you've been here, but like, why saying hi again? Okay. Do we always center at the singularities? Do we always center it at the singularities when we find the bad points? No, you don't always center the contour at singularities. You do that when you're choosing to deform the contour to simplify the integral. It's clearly separate the ideas because there are people who get mixed things up. So the original contour is given. You don't control it. You do not move or center the original contour. You find the singularities, check which ones are inside C. So I'd even draw small circles. This is a strategy, not a rule. Contour deformation. Then yes. Okay, so I'm gonna like when the singularities are inside the contour, then we do that, yes. Having singularities inside the contour is necessary, but not sufficient to do that. Isolated singularities. If you had a branch cut like log or square root, then you can't freely deform. Cross contour crosses a singularity, then the integral isn't even defined normally. You don't need to deform if it's already in CIF form. Just apply the formula, no shrinking needed. Your phone is about to self-destruct. Me? Bro, I kind of had like a dream about that. I don't know. You're using ChatGPT? I need to. That's how you study. Where are you from? Hello, Coco Mine. I'm from California. Smoke. Just joking, pal. Nothing's gonna happen. Alright. If that did happen, I would be a happy man. Just kidding, I'm not a man. But I'd be happy to not have to do this assignment. But life gets better, if you wanna end it here just so that you don't have to go through one small bump in the road compared to your future, which could be so much more bright and beautiful. That's not very smart. So simplify a contour using the Cauchy algebraic decomposition and properties of integrals. Evaluate a contour integral using Cauchy integral formula. So that's what CIF stands for. So how do you integrate Cauchy integral formula? Well, I think we're gonna go over that for the next question. Computing the integral here using CIF, right? Like, look at this graph, bro. Like, what in the world? Applying the CIF. So that's for 2.18.2. This is gonna be on the exam, on the quiz for sure. I want to just skip to this, but it's 11 a.m. We have a lot of time. We could do the next couple questions. Just one, two, and three. Three more questions. We got this. You will not get Cali. Don't worry. I don't study by showing the what? Hello, Albert Einstein. Welcome to the stream. Um, I don't know what that means, but the auto translation didn't really work. So Yeah, let me know how you guys are doing. I'm gonna leave by. No, Shelly, just tell me how your day is going. But yeah, if you need to go, you can. That's fine. But yeah, thank you so much for even joining the stream. I appreciate it, and see you later, inshallah. 1 minus iz dz. So this is the integral that we're trying to compute, right? Or the simply closed contour shown. his his book complex in like bubble writing, so it's like simply closed, but you can make it like any shape. It's just irregular. That's quite the art. So simplifying an integral over a simple closed curve. How do we do this? So the function sine e of z is entire, right? Sine uh what do you call it? Exponents, mm, polynomials. What else? Cosine. These things are always gonna be entire. That's why it goes to zero using the Cauchy theorem. You can use the residue theorem. What? Hello, Ghost. Welcome to the stream. How's it going? Tell me how your days are going, guys. Because mine just started feeling pretty anxious, but I'm trying not to feel anxious just because that's not helpful to any situation. Just makes it worse. You do worse in a situation where you're anxious versus when you're not, because your capabilities are the same in both situations. You just lose it when you're anxious. So log I log 1 minus iz is analytic on the split plane U with a slope from 0 infinity to negative I. Negative I? I know it's negative on the non-analytic on the negative real axis, but it is analytic. Picture below. Product rules and see simply connected. So that's okay. So this goes to 0, but being multiplied by this, the whole thing becomes 0 by Cauchy. Wow, it's pretty simple. But let's see how ChatGPT does it. Hi. What is the residue theorem? Did you just make that up? Contour integral of the memorphic function on the simply closed path is 2 pi I times the sum of the residue of the singularities and close by. That is a powerful tool for calculating complex line integrals. Wait, that's crazy. But we didn't really go over that. That's very smart. How'd you learn that, Fair Kira? If it's simply closed, it has to go to 0. E is entire, sine z is entire, composition of the entire function is entire. So this part is analytic everywhere. This is a tricky one. Log is not analytic everywhere. It has a branch cut. So the branch cut in the W is 1 minus iz plane. Translate back to z, this becomes a slit in the complex plane. Describe it going towards negative I. So the key question, does the contour C cross or enclose that branch cut? No branch cut is crossed. How's it not cross if it's entire? Analytic on the region containing C. Picture by the product rule since it was simply connected. There are no singularities inside. Where is the branch cut? Does the contour branch touch? How to tell where the branch cut is and if the contour touches it? It's like the main aspect. Hi, Ghost. It's probably gone now. Yuki is back. So the base function for log 0, yeah, I know that's the branch cut is on the negative real axis. But if it's 1 minus that, 1 minus iz, then w equals 1 minus iz. Now the branch cut is where? It's negative. So if we translate it, subtracting 1 on both sides, then iz equals 1 minus t equals 1 minus t over I. Negative I. Does the contour touch or cross that line? Crosses that vertical ray downward from negative I or encloses it. The contour stays in a region away from that downward ray. Doesn't touch or cross it. It does though. Like what? Look at this picture. It's going downward a little bit. That's weird. The contour crosses the branch cut. The function is not analytic. How would you put the answer simply? Z equals negative I, extending downward. Since the contour does not intersect this ray, the integral is analytic inside C, so the integral is 0. Can you say that since sine part is 0, then by Cauchy-Grasov theorem, will you multiply everything by 0, so it's 0? That doesn't work. Uh-oh. They're adding, not multiply. Now, what would you say about product rule? Entire integrand is analytic. Okay. So, how long is your lecture? It's like starts at 3, ends at 4:50, so it's like almost 2 hours. But the last 20 minutes is when the quiz is. Look at Yuki over there. Okay. So ray starting at z equals -1. Negative I, right? How do you use negative I again? Isn't it I times I -1? So if you subtract it, wouldn't it be 2? log z minus a log az plus b log z minus a over z minus b. Which class am I in? Hello, Shazad V. Welcome to a stream, and Arman Beg, welcome. This is complex variables. So let W no, let W equal 1 minus IZ. So then W is in the negative real axis, right? Because that's where log has a slate plane of the branch cut. So then we get this 1 minus IZ is in this negative real axis. IZ equals 1 minus t, z equals 1 minus t over I negative I times 1 minus t. Negative I times a real number is greater than or equal to 1. Hmm. Since contra avoids the branch cut. You just gotta know the branch cut is in the negative real, a negative imaginary axis from this. You seem confused. I am a little bit, just a little bit, because I'm not the best at graphing. But for this part, uses t, right? So 1 minus iz is equal to t, and then solving for z, we get z equals t minus 1 over I, negative I, so it's like negative t plus 1. So then that equals to, you multiply why did it become negative I? Oh, okay, so you multiply by negative I, because I times I is negative 1, times negative is 1. So then that becomes I 1 minus t. Okay, that's your z. So this is a real number. So where t is less than or equal to 0, a real number. So geometrically, that means so I minus t is greater than or equal to 1, right? Because initially we had t is less than or equal to 0. But if we like add 1 to both sides, then we get this. And the sign changes because this is negative here. So if that's the case, if it's less than or equal to 1, times multiplying by negative I, because I forgot it's a negative I on top and bottom, then it has to be any real number times the negative I. That just proves that log I minus iz, or 1 minus iz, is equal to the imaginary or negative imaginary axis. So it's analytic everywhere since the contour does not touch the, what do you call it? The ray? It uh avoids the branch cut, or the slit, right? So by Cauchy-Garcot theorem, it goes to zero. The integral is zero. Hello. Hi, Shilu Devi. I mean, you've been here, but like, why you keep saying hello? Like, I see you. You say something else. It's analytic on you by the product rule. What do you mean by the product rule? Simply connected it. See, simply closed. Contained in you. I gotta ask about the product rule. What do you mean? Um, what what does the answer mean by saying product rule? You don't mean the derivative rule. Two functions are analytic, so the product is also analytic. Okay, so this is byproduct rule. Since the contour does not touch the branch, so what goes to zero, but we missed a lot of extra words, like the product rule, and also the simply connected and the curve being simply closed, containing being contained in you. Okay, so we're done with that question. We just have to remember certain things like, um, hi, yes, I see you, Shield. Yeah, how's it going? We have two more questions. This one is also pretty simple, right? Just gotta use Cauchy-Garcot theorem to state that both are equal to zero, or goes to zero to both analytic, and by the product rule, both are combined as something analytic, with the thing being simply closed. So for the contour C shown, compute, let's see, sine z over 2z minus 2i. Finally, no branch cut or anything. So sine z is analytic. 2z minus 2i, that's also analytic. It's like a polynomial, right? That's so simple. But we're not doing the Cauchy-Garcot theorem, we're using CIF, using another theorem, because they're asking to compute it now. That's the problem. You don't know if you're gonna use CIF or the Cauchy-Garcot theorem. So over here, we can do the Cauchy-Garcot theorem. But over here, CIF, contrast positively oriented, simple, closed at centered at I, lying inside the curvature. So observe that this is entire. So if D is in the complex plane, then it simply contained an analytic on D. Therefore, if you were to compute this, you'd say phone battery increased and became 15 plus 2. You're doing such a hard work. Yeah, thank you so much. But yeah, that's so cool. Your battery went up. So Cauchy integral formula, right? This is the Cauchy integral formula. So when you see something in this format, the Cauchy integral formula is this: f of z over um c, the closed integral c. So the denominator is z minus z naught. When I don't put the line, it looks like a 2 sometimes. So that's important. So that equals 2 pi if at z naught. But let's see how. Two more questions, guys. And then we could go over everything, review everything. So we have to rewrite the denominator that way, so that it's like this, z minus z naught. Then we get z by itself then. So sine z over 2 times that, which is just half z minus z naught, which is z minus I, not z naught, z minus I. Now it matches the f of z is half sine z and f z naught is I. Matches what though? The Cauchy integral theorem. Cauchy integral formula. So check conditions, don't skip this, use SCIF, contour is closed and positively oriented. So CIF conditions, contour is closed and positively oriented. And then the other condition is that Z naught is equal to I inside C given in the problem. Right? Because the C, the problem is shown here. Like this is the, well, I didn't really show this, but this is the graph that we're looking at. So it has to be inside this simply closed form. I think you're missing half pi I, then times with the contour integral. Oh, where'd the pi I come from? What? You're right about that. Oh, how come? Well, I guess we're gonna simplify it later, though. Hmm. Also, the last thing is that f of z is analytic everywhere. just entire. Okay, so we have half sine z minus I, right? So to apply the Cauchy integral formula, that's 2 pi I times f of z naught equals 2 pi I times f of z naught. So we have 2 pi I times f of z naught, just the f is sine z, but the z naught is I. And we can't forget this part as well. So half. And that equals, well, it just simplifies down to pi I times sine I. I don't know if it's mandatory to have that clean answer, turning it to sinh or sin h. That's just so much work. I liked and commented and tapped some hearts. I'm gonna sleep. Good night. I'm really proud of you when I saw you working so hard. Good job, girl. Take it easy. Good to go. You got this. Thank you so much, Animatiz, and have a good sleep. Yeah. I hope that makes you motivated to work hard as well. It's a Cauchy integral formula, if I remember correctly. It is, yeah. And hello, Lava Edits. Edit, welcome to the stream. Good night, Wolfram Media. Have a good day. Thank you. Good night. Have a good sleep as well. So, sin h, right? Pi I, sin I. Sin I. What is sin h? Like, how? Man, we gotta remember all that as well. Can I just leave it as this? Pi I, sin I. Negative pi sin h. 1. Because for sin I, it's e to the I times I minus e to the negative I times I over 2I. And that's e to the negative 1 minus e to the 1 power over 2I. That is just equal to pi over 2 e to the negative 1 minus e, which is sin h centered at 1. That's so hard. Like, it's harder to simplify this than anything else in this problem. I don't think he's gonna ask this sin h thing. If he does, that's so rude. That's just me. Like, who does sin h anymore? Nobody learns sin h, Cauchy, that type of thing. So, understand step 5, right? That's a formula. And I learned that formula too. But step 6, well, I understand that too, because there's I on the bottom, I on the top. That just goes to pi over 2 times that. But then, how do you go to sin h? Forgot. How did it turn to sin h again? I forgot the formula for sin h. E to the x minus e to the negative x over 2. Oh, okay, so because it's like the other way around, it's a negative out there. So it's just negative sine h times 1. or with 1 inside. Negative pi sine h. So sine I equals what? Can you state the sine I identity too? I forgot that as well. So this is e to the iz minus e to the negative iz over 2I. And then for sine h, it's the same thing, but there's no z. E to the I minus e to the negative I times I all over 2I. And then sine h of 1 equals, wait, the sine h formula is equal to e to the 1 minus e to the negative 1 over 2. So that equals pi I times e to the I of, just I minus e to the negative I of I all over 2I. This cancels, this cancels. So this becomes e to the negative 1 minus e to the 1 over 2, but it's supposed to be the other way around for sine h. That equals negative sine h. But then you multiply by pi, so you get pi negative pi sine h for the answer. But like, not just by itself with 1 inside, right? Sine h 1. So it becomes negative pi sine. Because these are functions, right? You can't leave them by themselves. That's how you get the answer. Don't use that kind of notation. Just remember that. Oh, you're not dealing with the hyperbolic trig. Yeah, you can make that into the Euler function thing. Wow. Dang, you know the complex variable so well. Hi, yo, Prisha. Are you Muslim? Matic sounds like a Muslim last name. Don't use that kind of notation. You're going to be confused with I as variable and I as imaginary number. Yeah. I cross that out. Put that higher. You are now dealing. Okay. Hindus? Oh, okay. No problem. I just got confused because like Prisha sounds Hindu, Malik sounds Muslim. It's like, interesting combination. Euler's formula. What was that again? E to the negative I, or what was Euler's formula again? Equals 1. E to the I x equals cosine x plus I sine x. Oh yeah, sine x equals that. Yeah, that's Euler's formula. Hi Prisha. Hi Study Quill, welcome. Good luck with your studies. I also have a stupid exam on Monday. I'll be pulling an all-nighter on Sunday. I should start earlier, unlike me. I just started today and yesterday. And that's not enough time for sure. I think this will be on your exam at the trig tubular, I mean. Yeah, for sure. Sign to this. I wish I could just leave it as pi I sin I, but that's not gonna give me full points. I need to use Euler's formula and turn it into sin h as well. And like reduce it down to this. So it's simple when you go through all the steps and all, but when you look at it, it's like that's a lot of work. And then you don't remember the steps when you're there doing the actual thing. I'm prepared for the exam, but like I do not have confidence. Oh, that's the worst part. Like you're more qualified than you seem just because you don't believe in yourself. I just have to revise chem, bio, physics are done. Oh, okay, so you're just revising for chemistry. That's not too bad, right? Stoichiometry, pretty simple. Unless it's not basic chemistry, then you have to memorize all the mm, chemical bond names and stuff. Do you guys have those labs where you turn fire into different colors? That's always so cool to me. I did that like twice. All right, last question. The final one. This is 2.18.2. It's interesting but sometimes frustrating. Chem labs are the best in my opinion. It's so fun. Yeah, I always wish like I had like my real friends in the classes with me, but they're all taking like different majors, different classes, so you just have to enjoy it with strangers. I mean, you could make friends in those classes with the strangers, but I would prefer only with some friends. So, kind of need a little break. I do research in particle physics, by the way. Okay, no wonder you're so good at complex variables. Allahumma barik. That's so cool. Research in particle physics. Do you get paid a lot? That sounds really hard. Let's take a break. Do a wordle. Any guesses? Oops, sorry. I'm not really shrink the screen. I'm still a student. Dang, that's so cool. Alright, getting closer. I know S is not part of the word, but just checking for O and E in the places for N and T. Oh, wow. Muted? Muted color? Why did I think that was a word? It's muted, never mind. There's no E in it anyways. Any guesses, guys? Hi, yo, Ananiacs. Welcome to the stream. Nat Geo. No. Uh, Nate? No, there's no E or S. That's so weird. I don't know if five-letter words start with N with the middle word T. Middle letter T. Hotel. Hmm. It has to be A. What other vowels are there? N-A-T. This is so hard. Smart. Nature. There's no E in there though. There's no E or R. Smart. Neuter. Nans. But the middle letter is T. And there's no U either. And it has to be a real word. Natal. Hey, I got it. Awesome. Okay. So, going back to the homework. This was due a while ago. Everybody else understands these things immediately without the help of ChatGPT. But we're not looking at everybody else, right? We're looking at ourselves. We're worried about ourselves. We're not comparing. Comparing is bad. Comparing is the thief of all joy. So, numerator is a polynomial, you know, that's nice. But given by the fact that it's a ratio, it's rational, then we apply CIF. Top is nice, the bottom is not. So, applying CIF, what is that? F of x, f of z over z minus z naught, right? Equals to pi, what was it? 2 pi I times f of I. Not capital. Two pi I times f of I. So we want to get z by itself, right? How do we do this? Do we break it up into two parts? Problem at z equals negative I. It's not inside the contour from the diagram. So f of z is analytic on the inside and inside the contour. Z equals negative I. That's the problematic part, right? Because if it were negative I, the bottom would be 0. But Z is not with the negative I. That's the important part to see. Problematic, my bad. Problematic points are where Z equals negative I and Z equals I. Inside, outside. The 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 thing, the outside the what? The contour. And it's negatively so and it's negatively oriented as well. This is the twist. The contour is negative, that means it's a negative integral. So the negative sees the same curve but counterclockwise. For the positively oriented, it's this, right? For the original, for this one, we just multiply by negative. If it's negatively oriented, just switch the sign, that's it. So for the positively oriented, we're not looking at z equals negative 1, negative I. So this one we just get rid of, right? Pick the singularity at z equals 1. So then we get f of z over z minus I, because I is included in the diagram. If you look at the diagram, there's I inside the thing. What kind of integral is that? Integral? The closed integral. But yeah, welcome to the stream, Century Father and Ananiacs. Which country? I'm from California, so country, United States. I don't know if you could see that though. So that's what we're working with. But yeah, the thing we want to do times f of d naught, right? What was the formula? It's pi I, 2 pi I times f of z naught. Z f times z naught. So z naught here is I, right? So negative 2 pi I times f of z naught, which the z squared, so that's I squared plus 4 equals negative 2 pi I times, this is negative 1 plus 4 is times 3, it's to negative 6 pi I. I don't know if that's the answer though. It's negative 3 pi, how? So if we compute it, the bottom, oh, I forgot. Hmm. Computing f of I with the denominator equals I plus I plus I, but we're looking at z minus I. Why is it I plus I? Why is it I plus I for the denominator? If we don't include that, we're looking I minus C. California, how hard to live there? I heard they have so many problems. Is that true? It's true to a certain degree, given where you live in California. California is pretty big, but it's also very beautiful. So there's the problem of the inflation, right? Gas prices, living costs, rent, all that financial burden. There's homelessness, there's drug use, there's a lot of laws, but all those problems, they're more like in the city, like downtown area and like um, the big places. I'd say where I live, it's pretty chill. Actually, really chill. I love where I live in California. It's like, yeah, there are problems everywhere in the world, but where I live, it's okay. It's not that common. So z plus I. So we write it as z minus I, where f of z squared plus 4 over z plus I. We're not ignoring that. We're just grouping it into f of z. Why is it z plus I on the bottom though? we only plug into what's left. If z gets evaluated at z equals I, remaining factor and then z plus I equals to I plus I equals to 2I. So then that cancels, equals to negative 3 pi. So that's annoying. We get the right answer, but we have to plug it into z plus I. Oh, because we use z minus I for the CIF formula for this part, right? So we don't even look at z minus I anymore. Lemon juice. Yo, robot game, welcome back to the stream. Yeah, I remember the lemon thing, where it started from. Gov loan. So we're done with all the questions at this point. So that's a lot of questions. See, 1, 2, 3, 4, 5, 6, 5.5 pages of just all of that, and we have to memorize it all. Not memorize it, but understand it and remember it all. How's your day going, robot game? Alright, I think I'm gonna stop here just because like I'm done with all the questions and I just have to review for the next um remaining time that I have. But yeah, thank you so much for watching, everybody. I appreciate all the comments, all the support, all the um help and the advice by the researcher guy. Anyways, I'll see you in the next one, inshallah. Hopefully the quiz goes well. I have another quiz tomorrow, so I have to study for that when I come back. But yeah, thank you so much. Assalamu alaikum wa rahmatullahi wa barakatuh.